Life Secret is a European project coordinated by the Department of Energy, Systems, Territory and Construction Engineering of the University of Pisa and developed with the collaboration of West Systems S.r.l., Regione Toscana, the Department of Civil, Constructional and Environmental Engineering of the University La Sapienza of Rome, Leghorn Port Authority and the Dutch partner Lambda Consult. The aim of this project is to demonstrate that the sediment dredged from the sea bottom of commercial ports, characterized by heavy metal concentrations over acceptable standards, can be treated in a specifically equipped confined disposal facility by means of electrokinetic remediation in order to reach the compliance with such standards. Electrokinetic remediation refers to the decontamination technique based on the application of a difference in electrical potential to the contaminated soil by means of electrodes directly fixed into the soil. The electric field generated is able to trigger the displacement of the particles present in the soil. These move along the electric field by migrating to the electrodes inside the wells where the liquid electrolyte is present and through which they are removed. Seawater sediment contamination is an increasing problem for many ports and water bodies where commercial and productive activities are carried out. When contaminants exceed certain limits, the costs for managing dredging activities increase significantly, since remediation treatments need to be carried out under controlled conditions in compliance with environmental standards before sediments can be reallocated. The project has foreseen the realization of a demonstration plant set up within Leghorn Port. The plant was designed and built thanks to the collaboration of West Systems, the Department of Energy Engineering, Systems, Territory and Construction of the University of Pisa and the Dutch partner Lambda Consult. How does the Life Secret pilot plant work? Secret plant is mainly composed of a treatment basin made of prefabricated concrete elements waterproofed with a plastic membrane. A network of wells was built inside the basin. Each well consists of a slotted pipe covered with geotextile that represents the interface with the sediment. The wells are arranged on parallel rows at a distance of about 1 meter from each other. The 6 wells of each row are hydraulically interconnected. The electrodes of the same row are connected to the same pole of the current generator, positive or negative. The rows with positive polarity electrodes are alternated with rows with negative polarity electrodes. Inside of the wells flows the liquid electrolyte in 2 different and separate circuits, one for the positive pole, anolyte, and one for the negative pole, catholyte. The 2 circuits are connected to a system for recirculation, conditioning and electrolyte treatment. Once the dredged sediments were placed within the treatment basin, the secret remediation process was started. The electric field generated by the electrodes is able to trigger the displacement of the particles present in the sediment through the following mechanisms: electroosmosis, electromigration and electrophoresis. These particles move along the electric field by migrating to the electrodes inside the wells. Thanks to the recirculation and treatment system, the pollutants are retained in solution and subsequently removed. The plant was equipped with a system for acquiring and monitoring the process parameters. This made it possible to monitor in real time the plant operating conditions, allowing also the remote management of the plant. All the decontamination process data were stored in a dedicated database. The plant has been working for a total of 18 months. The lab tests carried out during the trial have demonstrated the effectiveness of secret technique in removing heavy metals from dredged sediments, highlighting at the same time the economic benefits and the relative constructive simplicity that make the secret technology a remediation technique protagonist in future scenarios.